Algebra 2.1, welcome back. This is now Unit 2, Complex and Rational Expressions. I'm Mr. Carlson. This is C-squared mathematics. Let's go through the bell work and then what we call imaginary numbers. So the bell work, what's going to be the bell work? Well, the bell work will be just Unit 1 tests, basically questions that I saw a lot of you missed. Yes, I have that ability. I can see how many times a certain student or the number of students missed this one question. So they are called the most missed questions. And I have a lot of them, probably about 5 or 6. I'm not going to spend a lot of time on certain ones like this, but I will be spending a lot of time on other ones like nonlinear systems or piecewise functions and stuff like that, okay? So make sure you have a pen and paper out, pencil, whatever, calculator, get Desmos pulled up, follow along as much as possible, and then we'll get started with the actual lesson. So Unit 1 test. We have a lot of questions to get through. Can I retake the Unit 1 test? Absolutely. You totally can. This week, you absolutely can. So it will be due by next Friday. So by next Friday, the Unit 1 test retakes will be due. If you forgot to take the test or you didn't get the grade that you desired, yes, you can absolutely retake this test, okay? In fact, you can actually look at the results from the Unit 1 test and see the exact questions that will be on the retake. Of course, there will be different numbers, but the same process of the question will be on the retake, okay? It will just be mixed numbers is all. So at least you know sort of what to prepare for. And these questions I'm going through right now will also be on the retake, will also be on the test, okay? So let's get started. Use transformations of f of x equals the absolute value of x to graph the following function. H of x equals negative 3 times the absolute value of x minus 2 plus 6. So first off, you can solve this completely by hand just using transformation knowledge. Okay. Second off, you can totally solve this completely by Desmos. Okay. So I'll show you both real quick. First things first, this negative 3 right here, what this tells me is that it's going to reflect across x-axis. Okay, why? Because it's negative. Now the 3, don't really get too bogged down with what does the 3 do. Technically, it makes it like really skinny. Okay, so the 3 makes it really skinny, but you don't really need to know that because on Math Excel it's just going to be A, B, C, or D, and it's going to be very obvious which one it is after I show you the rest of these transformations. Okay, negative 2, what does that do? Technically, it moves it plus 2, so right. Now, you're asking, what the junk? Why does it do that? Because remember, what this is saying is A times the absolute value of x minus some number h. H is just a variable. It doesn't matter. Okay, I can put whatever number I want in there, and then plus k. Notice how this is my almost like formula, and I just plug numbers in wherever I want. But notice this. This is what we call the built-in negative. Okay, whoa, that's a little bit too exaggerated. It's called a built-in negative. Okay, a built-in negative. So that means what we're really looking at is like this. Okay, x minus a positive 2. This is the number I want. That's really what we're looking at here. Okay, so it does move to the right. Now, what does this 6 do? This 6 on the end moves it up. So it's not kind of counter what you may think. Okay, like this is kind of the opposite. If it's negative, it's going to move to the right. This, if it's positive, it's going to move to the right, positive. If it's negative, it's going to move to the negative, to the left. So this says 6 up. Okay, so now what will this look like? Well, we always start at the origin, so it reflects down. It moves to the right 2, and then it moves up 6. So it's going to look something like this. Something like that. Okay, it doesn't need to look exactly like that, but it's going to be definitely in the first quadrant right here. The vertex right here is definitely going to be in the first quadrant, and it's going to be pointing down. So that's what I know it will look like. That's how you solve it completely by hand. Honestly, I thought this was going to be a straight up easy question. Like I thought this was going to be like, here you go, you're welcome. But apparently not. Okay, like it's that simple, guys. I don't know how else to stress it. It is literally that simple. So let's go to Desmos. Let's plug it in. I'm going to show you what it looks like. So go to your wonderful Desmos calculator, hit graphing, and you're going to go over here. You can even type in literally everything you see, even h of x, which is what I'm going to do. H of x equals, and then you have -3, the absolute value. Remember that button, if you hit shift, and then the button right underneath the backspace button, okay? So shift, and then that button will give you absolute value. If you don't want to do that, okay, you can go down here, and then you can hit your absolute value button right here. It's right above the ABC, okay? So either way, doesn't matter. Okay, x minus, and then 2, scroll over, and then +6. What do you know? Now mine's going to look obviously a little bit different, but it's very similar, okay? But like I said, it's A, B, C, or D. It's going to be very obvious which one it is, okay? And so this one you see that's right here, okay? This is your parent graph function, by the way, of x. So that's what it looks like. Now this one is really fat. This is what the normal absolute value graph looks like. This one's very, very fat. And so as you can see, your red graph, the graph you're actually interested in graphing, is very kind of skinnier, okay? Because the 3 is what makes it the scale. It basically makes it skinny, slim, skim milk, okay? So that's all I'm going to go through on that question. Let's continue on this. So this is a functions question. So functions question, what's the domain? Well, I read domain left to right. I read range bottoms up. So domain left to right, like a book, range bottoms up. So domain left to right. Does it exist right here? No. Right here? No. What about a -6 right here? No. -5? Nope, doesn't touch. -4 right here. It does touch. Okay, it touches something of the graph. Now, since it's a circle, I'm going to say -4 with parentheses. And then going to, it starts to stop exist. It starts stopping existing. Does that make sense? At this value right here. Now, this is not the y value I want. It is domain. Okay? Negatives come first. They always have to come first. What is my x value? My x value is 0, of course. So from -4 to 0, and now this is brackets because it's closed, this is my domain. Now what's my range? My range is going to be bottoms up. So my range starts at the very, very bottom. Where does the graph start to exist? At the very bottom? Not at -10 right here. At -9, it starts to exist. Is that closed or open? You should be saying it is closed. So -9, comma, all the way up, it starts to exist. It's still existing, still existing. At what y value does it stop existing? That's going to be 7. And since it's open, I'm going to do 7 and then parentheses. That is my range. Okay? That's it. Range, bottoms up. Domain, left to right. Okay? So x-intercepts, there is one x-intercept right here. That's at -3, so that's all I'm going to write. Y-intercept, there is a y-intercept right where we said it was, -9. And then -2. -2 is where you look on the graph. This is an x. So -2, what we call this is an x. So that means I look on the x. This is -2 right here. And I want to try to find where does it actually hit my y graph, my actual graph. And what value is that? -5. So it hits my y value at -5. Remember, input x, output y. Okay? Input x, output y. And your graph is the y. Okay? Sweet. So now that we got all that, let's continue on. So this one is a piecewise function. Okay? So there's a couple things here. It wants us to actually graph it and then find my domain and range. So the first thing I want to graph is this. Now before I actually graph, I want to show you what this actually looks like. What this is actually saying is y equals 3 where x is less than or equal to 0, and y equals -4 where x is greater than or equal to 1. This is what it's saying. Now let's make this line my blue line. Okay, so we'll do that one first. Y equals 3. Now y equals 3 is a straight line, okay? Just letting you know, it's a straight up line. So that means at 3 right here, it's a straight line. Now, if it's less than 0, am I going to start writing it over here? No, okay? I'm not, because it's less than 0. So that means I'm going to write it over here, and I'm going to start at 0 right here. I'm going to start right at 0 because that's part of my domain restriction. So I'm going to put a dot here because it's equal to, not an open dot, and that is my line, less than 0. Now what about my red line? My red line is literally the exact same thing, but at 1. So right here, or sorry, at -4. At -4 down here, but it starts at 1. Okay, so this is 1, and then it's also closed. Okay, so it starts at 1 here, x equals 1, but my y, my output is -4. And that's also greater than 1, so that means it's going to look like this. Wow, that's a pretty straight line. I'm pretty impressed. Now the problem with this is this little piece here. There's a space, right? There's a space in between. So since there's a space in between, I have to account for that when I go to my domain. So my domain, what is it? Well, it does exist down here, the whole graph, so negative infinity. Where does it stop? 0, brackets. And then how do I get from here to here? Well, we do a union. So a union, brackets, and then again, I'm towards my x values. My domain is my x. So I'm not going to do -4 here. Okay, I'm going to do 1. 1 right there, 1, because that's my x and domain is my x. So 1, okay, and then going to positive infinity. Now what is my range? My range is a little bit interesting, but it's already technically given to us. These two numbers, those are my ranges. But the problem is it only exists on those values. It doesn't exist down here. It only exists right here. It doesn't exist right here or right there or right here. It only exists right here. Okay? Which means it only exists on -4 and 3. And so what we're going to do is we're going to include little fancy braces there. And that is how I do my domain and range. I think Math Excel may want you to do it like from least to greatest, so -4 to 3. That's why I put it there. Sometimes it's maybe greatest to least. I can't remember. But probably that, -4 to 3. Awesome. Let's continue on, okay? That is how you do that piecewise function. So this is a rate of change question. So my rate of change formula is as follows. This is my rate of change formula. Just like slope. I mean, it's literally just slope, but big boy math. Okay, this is my formula, and so what I'm going to do is I'm going to plug in x sub 2 in here. I'm going to plug in x sub 3 in here. That's going to be my numerator. My bottom is just 6 minus 3. X sub 2, 6 minus x sub 1, 3. Okay, so let's start solving this. I'm going to use I am going to use parentheses, but I'm going to use brackets first. I'm going to plug in 6 here, so this is going to be 6 squared plus 7 times 6. And brackets, that's my first x sub 2, my f of x sub 2 minus, because it's a built-in negative. And then my other brackets, going to plug in 3 now there. So that means 3 squared, and then plus 7 times 3. All over, and this is 6 minus 3. So now let's start solving this. In my first brackets, 6 squared is 36. 7 times 6 is 42. And then my second brackets, that's going to be 9, and then plus 21. And then, of course, bottom here is 3. Equals 36 plus 42 is just 78. So I'm going to write down 78 right here. Minus 9 plus 21 is just 30. And then, of course, all over 3. What is 78 minus 30? That's going to be 48 all over 3, which of course gives me 16. This is what my slope is, my average rate of change. Average rate of change, arc. How about that? Okay, average rate of change. Awesome. Okay, let's continue. If you don't have that, if that doesn't make sense to you, go back to the other videos, go through the algebra playlist, find rate of change, graphing functions, and then I'll teach you on that video. Okay, this one, substitution method. I love this. This is a great method. First off, I am going to show you how to do it by hand. Second off, I'm going to definitely show you how to do it using Desmos. There's a couple ways to actually solve this, okay? And so there's probably an easy way and a hard way. I'm trying to do the easy way, and I'm going to manipulate this equation. You don't have to follow the substitution method, by the way. I am just going to, because it seems to me that this is a coefficient of 1 right here. It's way easier to do this by any other method than substitution. But I will show you how to do it with graphing. So what is this new one going to look like? It's going to be x equals negative 3y, and then I'm going to add that 8 over. So I just kind of did a flip around here, but that's what it is. So all I did was I added the 8 over, and then I flipped it. I added the 8 over, so negative 3y plus 8. The 8 goes poofy on that side, and then I flipped it like a pancake. That's all I did. Now that I have that, I'm going to take this, and I'm going to plug it right in there. Okay, the reason why this question is so difficult is probably because you have a negative 3y here. And so when you actually go to multiply that out, it gets really sticky. That's a lot of algebra review, which is why I'm going to actually show it to you on Desmos, because it's probably way easier to do it that way. But I want to do both. So this is going to be y squared equals negative 3y plus 8, and then squared. I literally just substituted it in for x. That's all I did, because if this is what x equals, that is x, then I can literally substitute it in for that x. But of course, I need to square it. So minus 64. This looks like pretty intense. So we're going to take it one step at a time. When I say squared something, it means double it. So it means double it. So that's what I did here. And of course, this is y squared. So now what do? Well, I have to FOIL it, of course. So that means negative 3y times negative 3y is positive 9y squared. That's important. It's positive 9y squared. 3 times 3, a negative times a negative is a positive. 3 times 3 is 9, and y times y is y squared. So I get all 3 points there. Positive, which I don't write, 9, and then y squared. Now my next one is my outer terms. So negative 3y times 8, that's going to be negative 24y. My inner terms, same thing, negative 24y. That's nice and cute. And then 8 times 8 is actually positive 64. And of course, I do have a minus 64 just chilling right here. And then of course, I still have a y squared here. Now you notice a couple things happening. This can be combined to be negative 48. And then the 64s go poofy. Isn't that fabulous? I think it's rather fabulous, okay? The negative 64s go poofy. So now, what do I have left down here at the bottom? I have y squared equals 9y squared. This is negative 48y, and then the 64s do indeed go poofy. Now, how do I do this? Well, there's a couple ways to do it. I'm going to want to combine. So actually, you know what? I'm just going to do it right here. I don't want to do it in the... I'll just do it right here. So I'm going to actually subtract this y over to make a positive 8y squared. So I'm going to take this y, that y term, y squared term, and move it over. So that means I have on the left side 0 equals, and then 8y squared minus 48y. Now this is very interesting indeed. A couple things that we can do. We want to simplify this as much as possible. So I want to actually divide by 8. Now, the reason why I divide by 8 is because both terms are divisible by 8. What I do to one side, I had to do the other, but it's no problem because that just becomes 0. And then this actually becomes, actually, I'll make this in purple. I'll make it in purple. This goes poofy, and so it still becomes y squared. And then negative 48 divided by 8 is actually negative 6. So negative 6y. Sweet. So now I can actually continue. I see that I have a y in both terms, so I'm actually going to factor out a y. So this is y minus 6. And now, since we follow our Algebra 1 skills, any product I set equal to 0. This right here is a product. This right here is a product. Yes? That's a product. So that means what I'm going to do is I'm going to take those two things, I'm going to set each one equal to 0. So y equals 0. Oh, look at that, I'm done. And then this one right here, y minus 6 equals 0, which of course is just y equals 6. So this is how I get my two values. Now, it looks like a lot of algebra because it sort of kind of is, but a lot of it is review. Okay, a lot of it is review for just how to factor, how to substitute, how to simplify different types of quadratic equations. We will definitely do a whole review later in the quarter, okay, just to recap and solidify everything. But for right now, that's how we get it. Now, I have two y's here, right? So that means I'm going to have 2 points, right? Which means I need to plug each point in to find my x. So let's find this one. So what is, if I plug in y equals 0, that means I'm going to have x equals, and I'm going to use this one. I'm going to use this one here, that formula, because it's already x equals something, right? It's already x equals something. So x equals, and then negative 3 times 0, because that's my new y, and then plus 8, which of course equals 8. X equals 8, which means what is my final point? My final point is in green here. I plugged in a y value, so that's technically my output, but I got out my input. That makes sense? So I have 8 as my x and then 0 as my y. That is my final first point. Now let's go to my next final second point. Let's plug in y equals 6. So I plug in 6, so x equals, I got negative 3 following the same formula that I'm kind of highlighting here, right here. Negative 3 times, and then I plug in 6, and then plus 8. Well, this becomes negative 18, and then plus 8, which actually equals negative 10. Okay, which means my actual point is here in green. My y coordinate is 6, but my x coordinate is negative 10, and then 6. And that is my final point. So what's in green here are my final answers with my smiley faces. And if you want to draw your awesome unicorn, you can, okay? So that is how you do it by hand. Let's see how you do it actually using Desmos, okay? So make sure you pause the video if you need to get this down. So I have y squared equals x squared minus 64, okay? Y squared equals x squared minus 64. Now, by the way, there's tons of different ways you can do this, okay? But y squared equals x squared and then minus 64. Now, this is what we call a hyperbola, okay? In mathematics, this is what we call a hyperbola. It's a very, very fancy word for hyperbola, or fancy word for a graph. Negative 3y equals x minus 8. So I'm going to type that in, negative 3y, and then equals x minus 8. I have this, a line, and what do you know? Those are my points. 8, 0, negative 10, 6. 8, 0, negative 10, 6. So that one was really easy just because you could have just plugged it into Desmos, right? There's no decimals, there's no radicals or anything. It's very simple, and honestly, probably most of you did do that, but it's that easy. All you had to do was just plug it into Desmos, and then you get the answer. Very awesome, okay? But this is how you do it by hand. It looks like a lot, but I assure you, it really is not. Maybe you're like, you're lying. I don't think I'm lying. I mean, maybe. But let's erase this, and then I have one more for you, and then we're done with the bell work. It's the exact same thing. Substitution, just kidding. Addition method, but it is the same thing, nonlinear systems. Now, what makes this question hard is it gives you 4 points. I mean, it's very difficult. So I'm not actually going to solve this by hand because it would confuse the vast majority of you. You can solve it by hand. If you're ever interested in finding out on how you solve it by hand, then let me know. I can show you. I'm actually going to show you a trick using technology. Using Desmos. Now, the reason why I like using Desmos is this, because you can use it to your advantage. Now, I know a lot of you did use Desmos on the nonlinear systems homework quiz, and that's why you took like probably 3-4 minutes, sometimes even 2 minutes, because all you had to do was plug all of them in, and that's awesome. Okay, I sure hope you're not cheating. You should not be cheating because that makes you an awful ignorant human being. And if you want to live your life as an ignorant human being in the cave, then sure, go for it. Or you can actually become an enlightened human being and actually learn interesting stuff. Okay? Actually grow yourself, transform yourself. Okay? So I want to show you how to do that using technology. So I'm going to plug these in and I'm going to show you a couple interesting things. And I'm probably going to finish the problem actually on Desmos. So I'm actually not going to come back here. I'm going to finish the problem on Desmos. So let's get started. X squared plus y squared equals 49. Now, if you're familiar with your geometry, first thing you should notice is this. It's a circle. Okay, I already knew it was a circle. This has a radius of 7, which is why you have a point right here. So 1, 2, 3, 4, 5, 6, 7. You have a radius of 7 because 49, the square root of that is 7. Okay, so my next equation is y squared minus 5x equals 49. So y squared minus 5x and then equals 49. So this is actually what we call a parabola. It is a horizontal parabola. It's not a function, and neither is a circle. A circle is not a function. It can be an equation, but it's not a function. Now, notice here you have a total of 4 points. Okay, you have a total of 4 points. Let me turn off the grid here. And kind of let me move it over here. So I want to actually work on this. You have a total of 4 points. Do you see that? Oh my gosh, are you joking me? Fine. Okay, I won't write until I absolutely need to. Now, notice these points here, and that's what I wanted you to notice. Notice this. You have 2 decimals. Okay? 2 decimals. Boom, boom. But they're the exact same decimals, just one's negative, one's positive. You have the same x value. Okay? And then you have 0, negative 7, 0, 7. Now, this tells me that the solution, what Math Excel wants, is literally 4 points. 4 points. That's what it tells me. It wants 4 points. You have to put in all 4. If you put in a decimal, it will mark it completely wrong. If you put in the decimal, will I give you the partial credit? Of course. Okay. I'll only give you half credit though. Okay. I won't give you the full credit. In order to get the full credit, you need to do what I'm doing right now. Now listen. You can, at this point, already put in 0, 7 and 0, negative 7. Those are answers, straight up whole numbers. Boom, you got half the problem correct. You got 2 out of the 4 already, 2 out of the 4. Because these are nice. So what do? You take 0, 7 in parentheses, 0, negative 7 in parentheses. You go to Math Excel and you type it in. Okay, that's what you do. You're already halfway done with the problem. Huh? Now, how do I get this? How do I get this? Well, notice they both have the same x value. In my problem, it's negative 5. You'll have something different. But they both have the same x value. What is that? Negative 5. So what does that mean? It means if you plug in negative 5, you will get out a y value. If you plug in negative 5 into either one of these equations, you will get out a y value. Doesn't matter which equation I plug it in. No. Okay? But you will get out a y value that's not a decimal. You get out a y value that's either a fraction or what we call a radical. So let's actually check to see if it's a fraction. 4.899. I go over here. I type in 4.899. I want to see if this is a good fraction. No. Okay, that is an ugly fraction. That does not help at all. Okay, which means this is more than likely a radical. So that doesn't help. Now I'm going to just take negative 5 and I'm going to plug it in into whatever I want, into a random x. Now because I want to do it nicely, I will probably plug it into this one. Does it matter if I plug it into that one? No. But let's just plug it into this one right here. Okay, so I'm going to take y squared. And this is going to be minus 5 and then times negative 5, the x, equals 49. This is y squared, and then plus 25 equals 49. And then I'm going to do y squared, and then 49 minus 25. What's 49 minus 25? 49 minus 25 is 24, right? So this is going to be y squared equals 24. Now, what do? Well, just like you solve any other equation, you want to do the inverse of it. We did learn inverses, okay? So that means, or at least the foundation of inverses, that means I square root because that square and the square root go poofy. So now I'm left with y equals. Notice I'm just by y. Now what the junk is this? First things first, notice that when you take a square root of something, you do so with a plus or minus. So I have to have a plus or minus. A plus or minus. Why? You have to have a plus or minus because a plus or minus, you can have negative 24 times negative 24, and that gives you, sorry, let me go back. You can take a negative times a negative, and it gives you positive, so positive 24. But you can also take a positive times a positive, and it also gives you that. So what I'm trying to find out is two numbers, like the actual square root of 24. When I multiply this together, I actually get 24. Okay, and since 24 is not a perfect square, it's kind of hard to figure that out, which is why radicals exist. So I need to break this apart. I'm going to break it up in 8 and 3. Why? Because 8 times 3 is 24. I could do 6 and 4 if I wanted to. It does not matter. Okay, so I'm going to do 4 and 2. And then this breaks up to be 2 and 2. Now notice here, this. When I break this up into what we call a factor tree, this is all Algebra 1 review, by the way. When I break this up into what I call a factor tree, I combine these together because they are a pair, and this is a square root. Square root means 2. And since this is a pair of 2, I can now move it out in front to be a solid 2. Why is that? What's radical 2 times radical 2? Radical 4, Mr. Carlson. Great. What's that? 2. Okay, so that's why I have 2 right here. Okay? Now notice I don't put radicals here, okay, because that's redundant. As a side note, I could do radical 24. This equals radical 8 times radical 3. That also equals radical, get ready for this. This also equals radical 2 times radical 2 times radical 2 times radical 3. Why is that? Because what's 8? Okay, 2 times 2 times 2, right? So this right here is really what I'm doing. See what I'm doing here in red. I'll kind of box it or cloud it in red. In red, that's what I've done. 3 times 2 times 2 times 2, all those numbers, when multiplied together underneath the radical, I get radical 24. So what I'm doing is I'm breaking it down in its what we call factors. It's what we call a factor tree, a radical factor tree. I just don't write the radicals here because that's kind of annoying, okay? That's why I don't write the radicals here because it's annoying, but you could like that, okay? So what is going on here? Well, first of all, this right here is the same thing that I clouded and kind of circled here. What's radical 2 times radical 2? Mr. Carlson, you silly goose, that's radical 4. Yes, which is 2. Okay, so that's what I write here, 2. Okay, now, can I simplify this? Radical 2, what's left over? Radical 2, this 2, or radical 3, that 3. Can I do anything with it? No. So 2 times 3 is 6, so I'm going to leave it underneath the radical. That's my y coordinate, which means I have negative 5, comma, positive 2 radical 6, and then I have negative 5, comma, negative 2 radical 6, because it's plus or minus. Now, let's check this. Are you ready? Let's check this. Let's erase all this junk. Did I get the right decimal? Is it the right decimal? Is it actually 4.899 or 889, whatever it was? So 2 and then square root 6. Boom. It's rounded to be the exact same thing as that. Okay? That is how you do that problem. Notice I barely did any substitution. I literally looked at these questions. I was like, oh, shoot, those are the questions. Those are right. And then I looked at these questions. I'm like, oh shoot, I can actually plug in -5, and then I can just basically skip like half the work. Okay, done. Okay, so that will be on your test as well. Feel free to copy this down, take a picture of it, use Desmos, use your resources. It's what makes you a good mathematician. So I'm going to erase. I hope that made a little bit more sense. Now let's go to our actual lesson. Imaginary numbers. This is Unit 2. It's what we call complex and rational expressions. Imaginary numbers. Yes, imaginary numbers. Do we have imaginary numbers in mathematics? Yes, we do. And we can actually use them. I'm going to show you what it is. So I can use the imaginary number by simplifying radical expressions with negative radicands. What does that mean? I'll show you what it means. So I'm going to tell you what is an imaginary number and how do you use it to simplify radical expressions with negative radicands. What does that mean? Let's get started. Make sure you get the essential question down. Imaginary numbers. Imaginary numbers. Let's go back to some radical review, okay? So I have these up here. Let's go back. What is radical 25? Radical 25 is technically just 5. Now, if you're like, Mr. Carlson, you silly goose, why isn't it plus or minus? Duh. It's actually just 5. And the reason why it's just 5 is because this is not an equation, it's an expression. So when we take the expression, it is just straight up 5. When I'm solving it in an equation, though, like this, I add the 5 over. I have x squared equals 25, radical, so this equals plus or minus 5. That's how I solve that. Okay, they're a little bit different. That's all fine and dandy. That's all great. You're probably like, okay, we did that literally in the last problem. Now, what about this? How can I solve that? Okay, well, this, I can actually solve it using this. Okay, I can actually break this up. It's what we call a difference of squares. X minus 5 and then x plus 5. Okay, I can break that up using what we call a difference of squares. And that's how I solve that expression. Now, of course, we're going to be reviewing that, a factoring review in a couple weeks. So hold on tight to that. But this is just basic review. Now, what if, let's erase, what if I have something different? Okay? I'm going to show you what that difference is. I'm going to actually show you why I have this. So pay very close attention. I'm going to simplify the following expressions. Okay? I do want to simplify the following expressions. I'm going to put them right here. Okay, in a little bit, but because the square, now listen very carefully what I'm about to say to you. Because the square of a real number is never negative, meaning if I take two numbers, two numbers, not 3, not 4, not 5, not 10, two numbers, when I multiply them together, okay, well, technically it is 4 and 10, but I'm not going to teach that to you. Two numbers, when I have two numbers multiplied together, I can never get a negative number. Why? Because if I take that negative, and especially if it's the same number, okay? So I can take a negative times a positive and I can get a negative, but if it's the same number, so negative times a negative gives you a positive, okay? A positive times a positive gives you a positive. That's what I mean. You can have a negative times a positive, okay? But when we're talking about square roots, that's just not possible because a square means double, right? So when I take the double of something, I can never get a negative. I can always get a positive. There's no real number x such that this equation is true, meaning I can never actually square an equation and I can never get a negative out. Now, to provide a setting in which such equations have actual solutions, mathematicians have what we called invented an expanded system of numbers, the complex number system. Yes, I said invented. Okay, math is slightly invented. Okay, maybe you thought mathematics was discovered in a way. It was actually invented and discovered. It's something that we don't know why we have the laws available to us, but we know that they exist and we know that they work. And we know that logic works, and that logic is the inbred foundation of mathematics. So let's solve these questions. What is negative 25 when I square root that? Well, if I go to Desmos.com, oh my gosh. Okay. When I go to Desmos.com, let's do square root of negative 25. What does it say, kids? Undefined. Okay? That's undefined. Now, what if I do this? What if I minus the 25 over? So I have x squared equals negative 25. What is that? Square root, square root. I get the same problem as that. And can I do this? Can I factor this? What if I factor it into minus and then x minus 5? Move my freaking face over there. Well, this right here is just x minus 5 squared, which is really just the same thing as x minus 10x and then plus 25. So it's definitely not that close, but how do I get rid of the middle? Do I just make it 0? I mean, do I make this a negative? How do I simplify this expression here? If I do x plus 5 and then x minus 5, what is that? Well, that's just x squared, and then that's negative 5, and then that's positive 5. So that's just going to be minus 25, because 5 times negative 5 is 25. But that's what we got before. But then if I did x plus 5 and then x plus 5, that would be x squared plus 10x and then plus 25. Well, shoot, that's not that either. So what the junk? Imaginary numbers. Okay? This is the imaginary number. We define an imaginary unit in mathematics with the following thing. I equals I'm literally going to call it I as imaginary, equals the square root of a negative 1. And yes, it's the square root of a negative number. Now, what if I squared both sides? Ready? Watch. If I squared both sides, if I squared that side and squared that side, what happens to the radical? What happens to the square? Mr. Carlson, you silly goose, they go poofy. Yes, they do, which is exactly what you have here. The negative 1 by itself with I squared, like that. So what does that mean for us? It means that these are highly connected. And if you don't know this right here, if you don't know this, you'll struggle throughout the rest of the unit. This is like the crux of everything else. I equals a negative 1 when I square root it. And then I squared equals negative 1, which means, by the way, I times I equals a negative 1 because that equals I squared. They all mean the exact same thing. And I equals what we call a negative 1. Now, square root of negative 1. Now, the imaginary unit can now be defined as this solution. And this is now, like I said, the basis of a new number system called the complex number system. So let's get into what the complex number system is. The complex number system is this. I don't want you to write all this down right now. I only really want you to write down this, like the set of all numbers in the form of a plus bi. This is the only thing I really want you to write down, because we're going to come back to this tomorrow and review it. So that means, what does this mean? This means that my a value here, okay, my a value is what I call the real part. I'm going to use a fancy symbol here, real number. Okay, it's my real number, all reals. Okay, so this fancy R right here equals all real numbers. That's all it means. Okay, all real numbers. Now this part, the BI, is literally my complex number system. So watch what I do here. It kind of looks like a C with a little line in there. Okay, almost like a cent sign, but not really. Okay, that's what we call my complex number system. My complex number system. Complex number. Okay, complex numbers are fun. I usually have students telling me that they really enjoyed complex numbers. Okay, complex numbers are really a lot of fun. Okay, I enjoy doing them all the time. Okay, and so Like I said, it's a pure imaginary number, my complex number system. So essentially, this is going to be the basis for the next 2 weeks or so. So make sure we know this. I am going to be reviewing this slide right here tomorrow. So if you don't write everything down, that's fine. Now let's actually get to simplifying. The whole rest of the day will be simplifying what we call imaginary numbers. What we call imaginary numbers. Okay? I am going to be using the form that I just showed you, the A plus BI form. Now the reason why I'm going to be using that form is because that is what we call the A plus BI is what we call the standard form. The standard form of complex numbers. So standard form of complex number system. Okay, so I am going to be using this form. I'm going to deal a little bit more with it though tomorrow in the next video. So I'm just going to let you know that that's what Math Excel will more than likely ask for. Here are your steps. Number one, whenever there's a negative underneath the radical, pull an I out. Okay, I'm going to show you what that means. And then of course we're going to simplify the radical afterwards. So this is going to be our first example. Are you ready? So we can't combine these, okay, because they're radicals. Okay, we can't just subtract them. So, -9 minus a -5 is this. This is not the correct answer, by the way. Don't do this. Don't you ever dare do this. Oh, so the negatives go poofy, and then I can subtract. So this is radical 16, which equals 4. No. Okay, no, 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 no. That's not the right answer. Okay. Did you hear my shout when I said no and then my guitar was kind of vibrating in the background? Okay. I really do mean that. Don't do that. You kill my cat when you do that. How do you not kill my cat? I like my cat. I want her to survive. This is how. You look at this negative underneath the radical. What this is saying, guys, this is saying a -1 times 9 minus, what this is saying is a -1 times 5. That's what it's saying. What is that saying? What this is saying is now I can perform this part. -1 underneath the radical times radical 9 minus radical -1 times radical 25. These are what we call properties of radicals, and we're going to do a full review of them in a little bit in the next couple days. But this is what we call the properties of radicals. Now look at this. Watch, 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 watch. Look at this. What is that? I. What is this? I. Okay? Notice how I'm pulling an I out. So what do we have left? Times radical 9, and then minus, and then times radical 25. And then all together, what is radical 9? Well, that's 3. So 3i minus, because they're times. And then what's radical 25 right here? 25 radical is 5. And then so minus 5i, which simplifies down to -2i. Okay, this is my final answer. If you wanted to put it in the actual standard form here, there is no real number besides 0 plus 2i. This is technically how you would write it with the standard form right there. Okay, that's technically how you would write it. 0 plus 2i. Because again, remember my a is my real part, and then my bi is my imaginary or complex part. Okay, that's what I say. So that's how you solve it. I am not gonna solve it like that every single time. That's annoying and it's boring. Okay, I'm just gonna simply look at, okay, you pull an I out. Okay, you see a negative in there, you pull out an I, and then you start simplifying. So let's go to another example. This one right here. I'm going to solve this a little bit faster. I pull out an I see a negative, I see a negative. So what I have is 3 times I radical 9. Then plus 4 times I, and then radical 4. What is radical 9? 3. So this is 3i times 3, and then plus 4i. Radical 4 is 2 times 2. And then 3 times 3 is 9i, and then 4 times 2 is 8i, and then this becomes 17i. That is my final answer. And if you really wanted to get technical, 0 plus 17i. Boom. It does say write in standard form. That's why I'm writing it in standard form. It does say that, so that's why I am writing in standard form. Okay? Just letting you know. So now that you kind of see how these work, notice one thing and one thing only. Notice that I is kind of treated like a variable here. I is sort of treated like a variable. Like it's almost as if it's like another x. And yeah, that's precisely the thing. Okay, the only thing that's different from I is that you literally pull it out of a radical, but once it's pulled out, you treat it exactly as you would an x. That's how you simplify it. So I hope that helps, and I hope that kind of solidifies in your mind that this is how we're supposed to simplify them. So let's erase this and let's move on. I'm going to go through these really, really fast. I have these pulled up, and I am actually going to go through them. After I go through the first one, I want to see if you guys can actually do the next ones by yourself. So let's do this one. I pull out an I, but what's radical 4? This is going to be 2I. Okay, I pull out an I, so because it's a negative, and then radical 4 is 2. Radical 36 is 6, and then I have to pull out an I, so this becomes negative 4I. It doesn't say anything about my keeping it in standard form, so I'm going to keep it like that. 64, so this is 6 times 8, because radical 64 is 8, but then I have to pull out an I, so make sure you tag on an I, plus 4 times radical 81 is 9, and then pull out an I, so this becomes 48I plus 36I, which equals 84. 84I. Try to do this one by yourself. Okay, pause the video if you need to. Okay, seriously, pause the video if you really want to try to do it by yourself. All right, so this is now my answer. Okay, I'm going to speed through these. I'm telling you, I'm going to speed through them. So 5I minus 2I equals 3I. If you got that correct, boom. Give yourself a nice unicorn. Awesome. Now let's erase. Let's continue on to multiplying. How do I multiply them? Well, remember to pull an I out. That's definitely the first thing I would recommend. Second thing is perform the actual operation, so in this case multiplication, and then simplify the radical. So when I have something like this, what this means, guys, is I'm actually going to double it. What does squared mean? Squared means double, okay? Squared means double. And so what I'm going to do now is I'm going to double this. So this is going to be negative 5 plus radical negative 16, and then negative 5 plus radical negative 16. Okay, now I'm going to pull an I. Remember, that's my first step. So negative 5, and then plus, now watch, I'm going to pull an I and perform the operation. Radical 16 is 4, pull out an I, so this is 4I. Okay, and then this is negative 5 plus 4I. Now notice I'm not going to town on multiplying the radicals. I'm not going to multiply these radicals like do my outer terms. That's freaking ridiculous. I can do this. I can simplify it even more right here by doing this operation. Okay, so now what I can do is what we call FOIL. Okay, remember I can FOIL it just like before. So my first negative 5 times negative 5 is 25. This is what that equals. 25. And then my next one in purple here, negative 5 times 4I is negative 20I. My next one in blue here would be negative 5 times 4I is again negative 20I. And then in like light green, 4I times 4I is this, plus 16I squared. So what is 4 times 4? 16. What is I times I? Treat it like a variable, I squared. Now, I start simplifying this accordingly. Okay, 25. This becomes negative 40I. Now, what is 16I squared? First of all, what is I squared? Remember, I squared is a negative 1. Okay, I squared is a negative 1. Okay, we learned that already. So I squared is a negative 1, which means when I simplify this, this is 25 minus 40I. And then this becomes minus 16, which becomes 9 minus 40I. Now, why do I put the 9 first? Because it's in proper term. Remember, it's my real number plus my BI form. Okay, remember that I squared equals a -1 and that I equals radical -1. This is the most important things that you could probably, on here, on that side, where I boxed, clouded, whatever, those are the most important things out of this whole lesson, out of the next lesson, even the lesson after that, okay? It's the most important things. You have to know this stuff, okay? What I clouded right here, that's what you need to highlight, you need to write down. That's important. Now, let's go through the other one. See if you can actually do it yourself. If you want to try to do it yourself, go ahead and pause the video. I'm going to walk you through it though. So what do we have here? Well, first off, I have negative. I'm going to skip a couple steps though. Minus, okay, I times radical 2. And then -6 minus I times radical 2. Now, notice how in the previous examples, we had a perfect square underneath the radical, but now we don't have a perfect square underneath the radical. So it doesn't just go poofy like this. 16 is a perfect square, turns into 4. 4 is a perfect square, turns into 2. 36 is a perfect square, turns into 6. 25, perfect square, turns into 5. We've used all those. 3, 9. 9 is a perfect square, turns into 3. So this case, we don't have that though. We have to keep it underneath the radical. Can we still multiply it? Of course we can. So let's do our FOIL. -6 times -6 equals 36. -6. Now here's the important part. I always have students mess up on this. Take it one step at a time. So negative times a negative gives you a positive. 6 times I gives you 6i. And then what happens to the radical? It just tags on. That's it. That's all. Not too bad, right? Not too bad. So right here, same exact thing. Nothing changed. So I'm going to write down literally the exact same thing, right? But what about here? Now, again, take it one step at a time. So right here is probably the hardest part, the hardest thing that students struggle with. What is a negative times a negative? Positive. Thank you. What is I times I? I squared. What is radical 2 times radical 2? That is going to be radical 4, which becomes 2. Okay? Radical 2 times radical 2 is radical 4, which becomes 2. Remember, guys, if I have radical times the same exact thing, it becomes 2. If I have radical 5 times radical 5, I have 5. If I have radical 3 times radical 3, it's just that number, 3. Okay? So notice all the similarities here. Okay? Whoa, I don't know what happened there. I'm going to leave it. Pretty cool. So now let's start simplifying. This is 36. Can I simplify these? Absolutely. Okay, I can just add the 6's though. I can't do anything else. Okay, just add the 6's. The radicals and then the I will treat it like we'll treat them like a variable. So you don't change the I here. You don't change the radical 2 here. You treat it like a variable. So I don't do anything with it. Just like 2x plus 2x. Do I do anything with the x's? No, this is just 4x. Okay, I just chills. Same thing here. The I and the radical 2 will chill. So what's 6 plus 6? This is going to be plus 12i radical 2. Now, what is I squared? I squared is a -1. And then I have times 2. So I squared is a -1. Just like right here. Times 2. Now, let's simplify this even more. This is 36. Not 32. 36. And then plus 12i, and then radical 2. And then this is minus 2. And then we simplify this. This is 34 plus 12i, and then radical 2. I kind of do look like, my eyes kind of look like a backwards J. And I do that on purpose because if I did 34 and then plus 12i, it just looks kind of weird. I mean, I don't know. I kind of like doing like a little curly tail on my eyes. I don't care how you write it. Same thing with pi. I know some students write it like this. Some students write it like that. I mean, it doesn't matter. Okay? Awesome. But that's my final answer, smiley face. Sweet. So I'm going to erase this. Then we're going to go to dividing. Dividing and then operations, and then we're going to be done. So dividing, how do I divide? Now this slide is going to be particularly difficult because of the fraction work that I'm going to do here. So you have to pay very close attention. Are you ready? First things first, I do really want to pull out an I. So the first thing I'm going to do is negative 20 and then plus I, radical 50, and then all over 60. That's what I'm going to do. The next thing I'm going to do is actually perform the operation. What does that mean? I'm actually going to simplify this radical. What is 50? How do I simplify this? This is 2 and then 25 because 2 times 25 is 50, right? What is 5 or what is 25? 5 times 5. Now remember, just like what I showed you during the bell work, that this is really what this is saying is radical 50 equals radical 2 times radical 5 times radical 5. Now what is this? I just showed you in the last slide. It becomes 5. What's left over? Radical 2, and that's what I'm going to do. So this is negative 20 and then plus I and then times 5 times radical 2. Now, I normally don't write it like this. I usually do 5 times I times radical 2, not I times 5 times radical 2. I am going to change it in a little bit, but that's what it simplifies down to. Now, if you had a lovely TI-36X Pro available to you at your local Walmart, it actually simplifies that for you. So if I actually type into my TI-36X Pro, if I type in radical 50, I don't know if you guys can see that, but it actually simplifies it for you. Isn't that wonderful? It's about $20. Ask your mommy and daddy, your parent and guardian, to see if you can get this lovely calculator. Desmos, unfortunately, does not do that for you, but it is a TI-36X Pro. It helps solve things. You don't have to do it by hand, you know? So maybe invest in that. All over 60. And if you ever do take trigonometry with me, we use this a lot. Just saying, we use it a lot. Now, what do I do here? Well, I notice I can actually simplify this in quite a bit. In red here, I notice every single coefficient or constant here can be divisible by 5. So I'm going to actually divide every term right here by 5. So negative 20 divided by 5 is negative 4. Plus 5 divided by 5 is I. So just one I. Do I write the 1? No. Just like you don't write 1x. You just leave it as x. Same thing here. I don't want to write 1I. That looks weird. I'm just going to write I. Okay? Just know that. So I, and then of course I still have radical 2. That doesn't do anything. And then all over. And then 60 divided by 5 is actually 12. So I'm going to do 12. Now here's the complicated part, and here's the part that's probably I'm actually going to put this in purple because we're almost done here with this problem. This is the complicated part. This is not in the standard form A plus BI. Okay, this is not in the standard form A plus BI. There's no fraction involved and has a number here. No, okay, we just want this, what I'm circling, A plus BI. That's not in the form of A plus BI, so we need to simplify it, and I'm going to simplify it as such. This is the hard part. Negative 4 divided by 12 plus I radical 2, and then divided by 12. Notice how I split it apart, and they still have the same denominator here. So I have to split it apart because that's what Math Excel wants. I need to split it apart. And then, of course, this just simplifies out very simply. Negative 4 divided by 12 is just negative 1/3. And then plus I times radical 2 all over 12. This right here is my final answer. Okay, that is my final answer. Now, they may want something different. Just to let you know, they may want this. They may want something like this, and then plus, and then radical 2 all over 12, I. They may want something like that where the I is out front. I do not know, okay? I cannot remember, but they may, I'm just saying, Math Excel may want this. Just saying, okay? Oh, that looks like a smiley face. Math Excel is fun, you know? All right, so now I want you to try to do this second one by yourself. Try to do it by yourself. try to follow, like literally try to get to the point where you can follow my steps almost verbatim, just different numbers. Okay, try to do that, all right? Try to follow my steps, pause the video, do it now, do it now. Pause the video and try to see if you really can do this second one by yourself. When you come back, I'm gonna have all the work shown, and so then I'll explain it very briefly. All right, welcome back. This is the final answer. So I first started over here where I just wanted to pull an I out right there. So I pulled out an I, and then right here you kind of see my simplified radical stuff. So that's my simplified radical junk. So 3 times 4, and then 4 can be broken down to 2 and 2. So 3 times 2 times 2 gives me 12. Do it, try it, it's 12. And then the 2's combine, and so they come out right here, and then of course the 3 is still stuck underneath the radical. And then the I, of course, is out. So I simplified there. Then what I did in purple here, I divided by 2 on each. So I simplified. -4 divided by 2 is 2. 2 divided by 2 is just 1, but I don't write it. It's just I. 24 divided by 2 is 12. And then I split up the fraction with a negative in front of the I right here. And then, of course, -2 divided by 12 is -1/6, and I can't do anything right there. Okay? So if you got that correct, you're awesome. If you're still kind of struggling, that's okay. Replay the video. Go see the videos on Math Excel, and I'm sure that they will help you. I'm sure that they will help. But it's kind of fun, right? Like I kind of like pulling an eye out, and in at least mathematics, I don't like pulling out eyes. Maybe in God of War, that was kind of fun. But like definitely, I'm not going to pull out a stranger's eye. That's sadistic. All right, so let's continue on operations. I only have these two, and I'm going to actually do them pretty fast here. So what are they? Well, this is, first of all, just pull on I, and then you're going to start simplifying and actually multiplying things through. So this is going to be an I and then radical 27. This is going to be an I and then radical 3, and then this is plus 27. Now, when I multiply through here, I can do that, by the way. When I do 27 times 3, I get radical 81. Okay, 27 times 3 is radical 81. But I times I is I squared. Okay, now plus, I have an I because it's attached right here. And then when I multiply here, what's 27 times 27? Well, it's a big number. But it doesn't matter because anything times itself when it's underneath the radical is that number. So it's just times 27. Okay, just like, again, just to reiterate, radical 3 times radical 3 is just 3. I don't need to do the extra step, radical 9, and then that equals 3. I can just jump right there, okay? So make sure you know that. That helps you. Radical 81 is awesome because it's just 9, and then this becomes a -1. So that's -1 times 9, and then plus I times 27. And of course, my final answer, put all together, -9 and then plus 27I. That is my final answer. Boom. Okay, now this one is a little bit more tricky, but it's okay because it just multiplies everything together. So I'm going to first pull out an I, so this is going to be 7, keeping in parentheses, I, and then radical 12. And then this is just going to be -8, and then this is awesome because radical -1 is just straight up I, right? Like I don't need to do anything else. Like that's great. And radical 1 is just 1, and then radical -1 is just I. So I have that. Now when I multiply this through, I have -8 times 7, which is -56. Take it one step at a time. -8 times 7 is -56. I times I is I squared. And then, of course, I have -12 here. Now this reduces down to -6 times -1 because I squared is a -1 times radical 12. And so this becomes positive 56 because a negative times a negative equals a positive. And then radical 12. And then I need to break down the radical 12. So 3 and then 4 and then 2 and then 2. Now you could do 6 and 2. You'll get the exact same thing. So this becomes 56 times 2 and then times radical 3, which is still left over. Now 56 times 2 is, of course, 112 and then radical 3. Now, this is actually a straight up number. Now, if it wants it in standard form, which it does, technically you need to add this. And this is the caveat. Are you ready? You need to add plus 0i. Okay, so you need to add the plus 0i there because that is still the imaginary part, the complex number part. Okay, and that's it. That's my answer. That's my final answer. So that's kind of how you combine the operations together when you just kind of multiply through and such. And that is the whole lesson. So I'm going to erase this. Hopefully you got that down. Let's continue. What did we learn? Well, we learned how to add and subtract imaginary numbers, multiply imaginary numbers. We learned how to divide imaginary numbers, and we learned how to perform operations with square roots of negative numbers. Okay? What are you going to do? You're going to continue on the imaginary numbers homework on Math Excel, and then you're going to go through the homework quiz. So hopefully you'll get to the homework quiz by tomorrow. If you finish the homework even today, you might as well just do the homework quiz because it's that simple. I tried to give you at least decently simple ones on there. Okay, but the retakes for the Unit 1 test, that's most important. That's going to be due this Friday. So the retakes for the Unit 1 test, that's going to be due this Friday. So guys, this is C Squared Mathematics. I'm Mr. Carlson. Thanks for staying and watching. Until next time, peace.